Your user searches for error KB4092 pod crash. Your vector database returns 10 results about pod crashes, container restarts, and errors, all semantically relevant, but none of them mention the actual error code. The real answer is buried in a support doc that vector search completely missed. This is the fundamental flaw of pure vector search. It's amazing at understanding meaning, but terrible at matching exact terms. Today we're going to fix this with hybrid search, and by the end, you'll know exactly how to implement it. Let's start with BM25, the algorithm behind traditional search engines since the 1990s. It tokenizes your query into keywords, looks them up in an inverted index, and scores documents based on term frequency and inverse document frequency. If a rare term like KB4092 appears in a document, BM25 gives it a massive score boost. BM25 excels at exact term matching, error codes, acronyms, product names, but it completely fails at synonyms. Search for car and it won't find documents about automobile. Search for how to fix and it misses troubleshooting steps. No semantic understanding at all. Vector search is the opposite. It embeds your query into a high-dimensional space and finds the nearest neighbors. It understands that fix, troubleshoot, and resolve all mean the same thing. It handles paraphrases and even cross-language similarity. But exact term matching, error codes, and IDs, it's hopeless. The obvious solution, use both. Run vector search and BM25 in parallel, then combine the results. This is hybrid search. But the key question is, how do you merge two completely different result lists with different scoring scales? Enter Reciprocal Rank Fusion, or RRF. It's the most popular fusion algorithm, and it's beautifully simple. For each document, take its rank position in each list, compute 1 over k plus rank, and sum across all lists. The constant k is typically 60. Here's the magic. Say doc A is rank 1 in vector search and rank 2 in BM25. Doc C is rank 1 in BM25 but rank 3 in vector. When you compute RRF scores, doc A wins because it appears at good positions in both lists. Documents that show up in multiple lists get boosted. That's RRF superpower. Why does RRF work so well? 3 reasons. Its scale-independent BM25 scores range from 0 to 20 while cosine similarity is 0 to 1. But RRF doesn't care because it only uses rank positions. There are no weights to tune, and documents appearing in only one list still get ranked fairly. Sometimes you do want control over the balance. Weighted hybrid search lets you set an alpha parameter. Alpha of 0.7 means 70% vector, 30% BM25. This sweet spot works for most RAG applications, primarily semantic with keyword search as a safety net for exact matches. The good news? Major vector databases have hybrid search built in. You use prefetch with both dense and sparse vectors and set fusion to RRF. It's a single hybrid parameter in your GraphQL query with an alpha value. Even SQL supports it by combining with. Let's recap the practical takeaways. Hybrid search is mandatory for production RAG. Pure vector will miss exact matches. RRF is the safest fusion method with zero tuning. Alpha 0.7 works for most applications. And BM25 handles the long tail of error codes, IDs, and names that embedding simply can't capture. Next up in this series, re-ranking. Hybrid search gives you a solid candidate list, but the top results aren't always the best. Cross-encoder can rescore each result against your query with much higher accuracy. Subscribe so you don't miss it, and drop a comment if you're using hybrid search in production.